The way I'll begin today is I'll begin talking about the weight notifying mechanism, a little bit about contention and starvation as well, and then I will go over the write-up of the homework. I definitely recommend, if you did not spend any time on trying to understand the current homework yet, I definitely recommend that you try out right away, right after the lecture, because I can say with confidence that you will most likely need more time than the previous one to finish this one. Okay. All right, let's begin. Last time we were talking about at the very end of the lecture, we were talking about synchronization mechanism. So we introduced the synchronized keyword, and we mentioned that there are essentially three different ways that we can use synchronization. One is in the signature of a static method. The other is in the signature of a non-static method. And the third one is a synchronization block. So you use at any point in any method, you can introduce that block, and then you need to explicitly specify an object that would act as the lock. In the first two cases, the object would be either the class itself, or the class object, or the instance where you have that method executing. In the third case, the case of the block, synchronization block, you are specifying the object. So it can be any object that you have created in your Java program. Because you have the possibility of having multiple threads arriving at a lock and possibly needing to wait before moving on, because as we have mentioned, the lock would only give one thread the right to execute. So it's a mutual exclusion mechanism, meaning that a single thread that would be approaching that lock or would be trying to acquire that lock would be allowed to do so. The other ones that would be in a similar situation would need to wait until that lock is released, and that lock would be normally released by the thread itself. When that happens, there is no guarantee whatsoever, at least if we don't create any mechanisms to that, to make sure that the rights of the use of the lock would be in a way fairly shared. So if I have, let's say, 10 threads, and you have these 10 threads trying to acquire the same lock, there is no guarantee that I would have roughly 1/10 of the time each of those threads acquiring that lock. What can very easily happen is a situation that we call starvation. So starvation means that a thread just keeps trying, never really acquires the lock. So it might be the case that a thread that is waiting for a lock never actually acquires that lock. As I said, there's no guarantees on that. A typical case when that would happen is when you have one of the threads in a loop, just acquiring the lock over and over and over, and then that might easily end up with that same thread picking up the same lock, and the other ones just waiting, not getting. Right? Is that guaranteed? So that's also not guaranteed. So like both extremes are not guaranteed, but because this mechanism is something that is also to some degree beyond our control, we will actually see some ways that we can go around this problem. But this is actually a typical conceptual parallel problem, right? So when you have multiple entities, multiple threads, multiple agents disputing some mutex or some lock, you would very easily have this kind of situation, like this kind of dispute. So there is some contention happening. We will not talk about that lock right now. We'll talk about that lock possibly not even today. I want to start talking about the wait notify mechanism. The wait notify mechanism is a very, very important mechanism that we would see on Java. The wait notify mechanism is essentially a built-in mechanism that allows threads to be put themselves in a wait state. So now here, when I say when I was previously mentioning that a thread would possibly wait for a log to acquire, this is a similar situation, and this is even related to the same state that is called the wait state. So when a thread is in the wait state, this means essentially that a thread is waiting to be notified. So it's different in the sense that when a thread is just waiting to acquire a lock, this is a automatic process, so you don't need to do anything. The thread will keep trying by itself until it is able to acquire the lock and then move on, right? In this case, when I call this wait method, I am putting the thread in that wait state that would not be left until the thread is notified. So this means that the wait is a way for normally the thread itself will be put in that, but that's also not generally true. So this means that the thread would enter that wait state, and then it would need to explicitly receive a sort of a signal that would be the notify signal that would allow it to continue. All right. There's a difference between the notify and the notify all. The difference is just that when you call the notify, some thread that is waiting on a given lock would be notified. So you don't have control on which specific thread would be notified, but you know that one of the threads that are waiting will. So only a single one would be notified out of the how many you have. When you notify all, you would have all the threads receive that signal. So all will be notified and all would potentially resume.
Only notify one. There's no way we can know that which one of the thread will get released.
No. I mean, you can after it is after it receives. So there are ways for you to check if you use some sort of identification or something that distinguishes the threads, right? So you can, to some degree, do that, and possibly take action, but not before that. Okay. Any questions?
If you have instance access to instance of a thread, then can't be apply notify method is then no method to apply a specific thread.
If you have an instance of a thread, then what?
Can you apply notify on the specific thread?
So the notify would be called with respect to some lock, right? So the object that is used as the lock would be the thing that would determine the threads that would be associated with that lock. Okay. But that's always the idea of the lock involved in the wait notify mechanism. Okay. Questions? Clear? This is just there's one interrupted exception that can be thrown. We will explore a little bit of examples on that. There's also a variation of the way that you can actually set a timeout. So it would automatically, after the timeout is reached, it would automatically resume. These are just yeah. So here in this diagram, we are just showing precisely what I have described already. So imagine that you have these three threads, and you have the first thread entering the wait state. So when thread T1 enters the wait state, so then you would have the possibility of the other threads moving on. When a thread enters this wait state, the lock is released. So that's also a very important thing to remember. Okay, so the lock is not kept. And then this means that the other thread obviously can go ahead and acquire the lock. So in this case here, you have the second thread executing here. And then at some point you have thread 3 also calling wait. So then this would also means that thread 3 after this short amount of time here of execution, it would enter the wait state. Then the only other thread left would be the T2 again, right? Because T1 would be in the wait state, and then T3 as well. When you reach this point, T2 is executed, and then T2 might call notify. When it does notify, so one of the other threads would continue, right? In this case, T1 is continuing. So then T1 goes, and then T2 can keep going. When you call notify, nothing happens in terms of logging. So you don't release the log, you don't do anything, any change to the thread itself. So this would impact all the threads that are waiting on that object. And then because T3 did not receive the notify, it's still in that wait state until it receives the notify signal. Yes.
So is the wait state kind of like a queue? So if
No.
so it's just random which thread.
Random. Yes. It's not a queue of any. There's no implicit or explicit order in terms of which thread would be given, would be receive the signal. Okay.
And wait would be used for synchronization, right?
You can create synchronization, more involved synchronization. We usually refer to those as protocols. So you can create protocols, sequence of events that would happen as a consequence of the way that you set up your monitor. So in this case, the monitor that I'm referring to is the monitor design pattern, not the lock itself. So when I say monitor, I usually refer to a combination of classes that uses the wait and notify mechanism. So there's usually one lock that is the class that would be calling the wait and notifies itself. So that act as a sort of a gatekeeper that would allow access to some execution or some resources to be accessed. That monitor idea would normally what you would see in more complex synchronization in scenarios.
Without this specific use case, there won't be any other thing that I would be doing with wait, right? Usually.
There's a lot of things that you can do with wait and notify.
Let me
Yeah,
figure out.
a lot. These are, you can think of it as primitives. So these are primitives that could be used paired, right? So you always pair up wait calls with notify or notify all calls. So you pair those things, and then you would be able to create some interesting scenarios. And that will be the next example that I will show you guys.
Setting the thread priority is anyway
It is even so not guaranteed to, yeah. So that's an interesting thing, because the priority is a signal that you would pass again to the OS. So the OS is receiving that. It might completely just ignore that and not even take into consideration. It might consider that. Usually it does consider the priority, but this does not guarantee that you would have a preference when you try to acquire a given lock, or that you will receive a notify. You'd be prioritized to receive a notify versus the other threads that are also waiting on the same object. Okay, so you cannot consider that at all. I don't usually even mention that priority because it's a completely unreliable mechanism. So I don't even like to actually rely in any way of priority.
Priority might not be the priority for the OS.
It might get, it might not be. Yeah. There's no guarantee.
When the execution or notify will happen, maybe the priority isn't the priority for the OS.
Yes, maybe not. So no guarantees, right? So, and you don't want to play with, like, you definitely want to have some determinism, at least on the flow of execution that you would have seen in your program, right? So there are definitely ways that we can do, and I will show a lot of more complex setups here to have some sense of control over what happens. So then you can then you can be a little bit more sure that some given set of threads would be the ones that would be receiving the notify, or one specific thread would be the one, even though you have multiple threads, one specific thread would be the one that would be receiving the notify. Any more questions? So This is a typical, so this is what we call the monitor design pattern. The monitor design pattern should not be considered confounded with the monitor as the log. So if you actually check the document, the Java tutorials, the Java specification, you would see the term monitor referring not to that idea, but referring to the lock itself. So when you have an object that acts as the lock, so we the documentation would say that every object in Java is associated with a monitor. So this means that any object can be used as the lock, as the mutex that would determine the mutual exclusive access to that resource or the mutual exclusive execution. Okay.
This monitor won't be referred anyway in the documentation, right? Because this is more of a structure.
Yeah. So the way the reason why we even use these nomenclature is because perhaps especially because of the way we set up the homework. Because the way that we set up the homework, we want you to use these design pattern that I'm going to show here. That is essentially one of the ways that you can use the pair of wait and notify alls. So that's what we call
It's
the
not
monitor.
When you're saying that this might be the standard nomenclature that everybody.
This is not standard. Yeah, this is actually not standard. Yeah. Perhaps I even considered a lot of times actually to even remove that monitor and just calling this something else to not create this confusion. But as long as you understand that these two things are not the same. So one thing is the lock, one thing is just the mechanism that every single object in Java uses to implement the lock, to implement the mutex. Is one thing. The other is that pattern that we see here. So here in this example, what I have is I have a method that is synchronized. Okay, I have another method that is synchronized. And then I would have one method that would be at some point calling the wait. The wait would be called on which object in this case? The object itself, right? It's synchronized, so the object itself would be the lock to be used. So the wait is calling on these objects. So the object that is currently executing would have the running thread put in a wait state. Right? So if you have that object, you can have many threads accessing the same object instance, right? That's perfectly fine. So every time that you have one thread entering that method and executing that wait, that would be put in a wait state. That will be pausing that that method. Because it's put on the wait, does that mean that it would release the lock? What do you think? I mentioned that.
Yeah. Really.
Yes, it will. So when you have a thread entering the wait state, it does release the lock. Okay.
So releasing apply the law.
Release. So this method is synchronized, meaning that it would only execute when one thread has exclusive access to the object itself, to the instance of that has that method. Okay.
It's almost like producer consumer problem. That
Yes, that's the next example that I would show consumer producer. Yeah. Exactly. Okay, makes sense. So then you see one thread doing the wait operation. You have a paired method that is now doing the notify, right? So you have this idea that you have two different methods that could potentially either be calling wait or notify. So every time that you see this pairing, then that's when we call this the monitor structure. This doesn't mean that you would have only waits in a method and only notifies in another method. Right? So you can actually have both calls in the same method. Okay, just to make sure that this is not the exclusive way in which we would see this being used. Okay.
Generally, how would thread remember, like after going to the block state, I need to go to run state, how would it remember like where to start from? It will be in the middle, right? Generally, after the start, where it should execute.
So what do you mean remember? So it's a.
I mean, it has the middle, right? After that, it again goes to the state where it should start from. It is like again this dot wait. After that, whatever the logic is there, it should execute when again it reoccurs the lock, not from the starting.
So it's just the regular flow of execution. And if you're asking about the state of the data that it might potentially access, you need to explicitly control that to make sure that these access are consistent. every time that you have data that is shared, so a shared resource like a shared field among multiple threads, you need to control the access to that field. So every time that you have threads potentially access that, you need to synchronize, create a synchronization block or create synchronized methods to make sure that this is an exclusive access. So that creates that idea of the first example that I showed of the atomic operations. You have a couple of a sequence of operations, all are treated as one single thing because these are inside a synchronization block or a synchronized method.
So here in this case, this dot wait after notify, it releases the lock, right? I mean, before releasing this dot wait.
The wait will release, yes.
After
Yeah.
that, it reacts as a lock, it executes.
When some thread called notify, it would be woken up and potentially acquiring the lock. It would try to acquire the lock. If it's not able to, it would just keep in that state that would be waiting for the lock to be available.
So when it executes a lock, it will start from the, like, again, re-execute the method again.
It would continue. Next line. We just go to the next.
Like,
Yeah. There's no interruption of flow of execution, right? It's just like a pause. So if you are in this line here, you'll be in that line until you are notified. Then you go to the next line.
So if I understand it correctly, notify will trigger the wait, is it?
The notify would wake up the threads that are on the wait state. A thread that is on a wait state is in a state that it needs to be notified by some other thread.
Wait means lock.
Wait means that it's suspended.
Is it not?
It's paused.
Okay, is it not same as lock?
No. So the wait would be specific to a lock and the notify is specific to a lock. I have a number of threads that are being synchronized on the same lock, that are sharing the same lock. The lock is the one thing that would be used to give exclusive access, exclusive execution.
Yeah.
So if you have 1,000 threads, when one of those 1,000 threads acquire that lock, only that one would be able to execute. All others would need to be waiting.
Okay, I know it.
So it's similar to the idea of the wait, but it's not, as I mentioned before, it's not the wait state when you are just waiting for a lock, but it's a similar concept.
I actually got a little bit confused.
When a thread completes its execution and calls wait for itself, it should notify the other threads, right? But it's not in the same.
It should be notified, right? So when you call wait, you would be put in the wait state. So if you are not using the timed out wait, you would need to be notified by some other thread. There's no way for yourself to be woken up.
Same thread could notify other threads that I completed my operation.
If it is running, it can, yeah.
So just to confirm, there is no way to actually decide which thread it will wake up, right? Like when we call
Right.
it is like any thread except itself.
Right.
Sure.
If you use notify all, every thread would be woken up, right? Yeah. But if you use notify, then one would be, and you don't know which one.
Maybe there's some use case.
So if we use notify all, then every thread will be trying to acquire a lock.
Yes. Which one would be? Would be getting it? You don't know, right?
So method B should be continuously called by some other thread to check if some thread went to a wait state.
That's not a very good idea in terms of design, because that's kind of in the realm of that busy loop that you just keep trying. And you kind of, it's better to think about this as an event-driven programming technique. So it's better than just when you realize that you changed something that could, that means that you are in a different state, and now a thread that is waiting now potentially is now capable to move on to acquire the lock. So then you go ahead and call notify, right? The producer consumer example would be the typical example, and that's the next example that I will show on that.
Locking will be usually used with wait and notify, right?
Say it again.
Locking, the lock would usually have a wait and notify as well.
So the wait and notify are with respect to some object, which is a lock. It's always associated with a lock. Good. Any more questions? So let's see there's still one more example here before we get into the senior producer example. So here I have, actually here I have I think something that I did not show or mentioned before. Did I show examples of anonymous classes yet? No, right? So take a look at this line here. So here, what I'm doing is that I'm creating a variable called thread1 of type thread, and I'm initializing a thread class. So I'm calling, looks like I'm calling the constructor, right? But then I have curly braces here. What does that mean? So this is the typical signature of a anonymous class. Why? How should I understand that? So you should understand that as you creating a class
Over here.
that would inherit from thread, but would be potentially overriding anything that I see in thread. So this is anonymous because this class do not have a name, right? It's a class that is not the same as thread because I am changing things, right?
Over here.
Yeah, but it is a class. It is a class, and I am instantiating that class.
So is it like the way lambda functions are like without a name, but like is a functionality the
Similar, yeah, not the same thing, but yeah, similar.
Yeah.
Okay. You got the syntax here. So after you just see the curly braces after the constructor of a class, you know that that's already an anonymous class, right?
In this particular case, the anonymous class would usually be beneficial if I'm only calling it once somewhere.
Sure, yeah. Yeah. Otherwise, you need to like keep
Yeah.
repeating the code. So that's the typical case to actually create a class, name it, and do the things that as we are used to, right? So this is typically used when you have one specific use for that class and one single time. So, and you don't really care how that class is going to be called, right? So you just want to implement that. Right. So in this case, I am implementing run because I want to specify what happens, right, when that thread is executed. So now here I am using synchronization block. I'm using the lock, this lock here as the object. Then I'm doing some things here. At some point I would call wait. Notice that wait needs to be inside the try block, right? That's because of this exception here. So I call wait. When I reach this point that I call wait, the thread would be paused. And then I would need to have other thread calling notify on the same object for this thread to continue. Okay. In this code here, until here, you don't see that. So there's no notify yet, right? But there's more to that code. So this is another object that I'm creating. Again, another anonymous class. Now I am using a similar structure here. I'm using a synchronized block on the same object, right? Because this is the same object, then when I call notify that object, the other thread, if it is in the wait state, then it could potentially be notified. Okay. So now an interesting question. Is it possible for this code to actually not notify the first thread?
Yeah, because it is executing parallelly. What if the second thread executes first? There is nothing.
Nothing here is saying that thread 1 would go first and then thread 2 would go next, right?
Yeah.
I can have thread 2 running before thread 1.
Yeah.
So then it would notify, and then thread 1 would go and wait, and it would be waiting forever.
Yeah.
Okay. Good example, right?
Do we need to synchronize that? Then how do we ensure?
No, so that's not the problem. There is not the synchronization. The problem there is so this is more related to a deadlock situation. What is it? You could use join, yes, yeah. Okay. Let's move on to the producer consumer example. So the producer consumer example here that I'm going to show is the usage of the wait notify mechanism in the monitor structure. I have my main program here in this class. I have a class that creates the producers, and I have a class that creates the consumers. So the idea is that I have a sort of a safe box that is like a storage that is obviously limited in how many elements it can store, right? So if I put one element there, that's as much as I can put there. So this means that every time that a producer go ahead and produce an item and put in the safe box, so another producer obviously cannot do the same thing because the box is full already, right? The consumer can come, and if the safe box has an item there, then it can consume, it can retrieve that item, right? But if the safe box is actually empty, it will not be able to do anything because it will try to get something from a box that is empty, from a safe box that is empty, right? So there you have these two situations where both the producer and the consumer would potentially try to add or remove items from that safe box, but would not be able to, would need to wait before it can move on. So this gives a little bit of a hint on what we would see in terms of implementation, right? And the methods associated with either adding or removing from the safe box would be these two methods. I think I'm gonna go with the code, so then I'll go back to that diagram, okay? So let's take a look first at the consumer and the producer. My consumer, let me make this bigger. Is that good enough? So my consumer is a thread class, so a thread subclassing thread. I am keeping a reference of my safe box here. My constructor is essentially receiving that reference to the box and storing here, right? And then doing the same thing for the number, just an identifier. My run method, that is the one method that would actually be running every time that I call start on the threads that on the consumer instances that I create. So here I am going over 0 to 9. I'm going 10 times, and I am going to try to retrieve the item from that safe box. So I would essentially try to do that 10 times, right? This is just inside that for. So notice that here I don't have any wait or notify or synchronize or anything, right? The same overall structure you would see in the producer, but now instead of actually trying to retrieve, you would be trying to add elements, insert elements to the safe box. So the constructor would be the same thing. I will talk about this in a bit. The run would similarly go over 10 times. It would get the next value, and then it would try to put that value in my safe box. Again, this is not something that would necessarily be possible to be done immediately, because my safe box might be full, right? So not necessarily this would happen right away. Again, I don't see any wait notify being used here, right? So we'll get there. And here I'm just printing out some messages, sleeping for a little bit, treating the exception. Now let's talk about this guy here. So why do you guys think I need to synchronize this next value method? And next value is working with this guy here. Yes.
If you have multiple producers that are trying to put into the box, and one puts in the box, the other one has to know that the value got implemented, so it has to wait.
What possible problem can happen if you don't synchronize?
Like, one might to go put into the value of 1, get interrupted, the other one puts the value of 1, and put 1 again.
Right. So you miss an update, potentially miss an update, right? So that's the loss update problem that we have, that we are seeing here. Anybody want to add something? So the value is a shared variable among all my instances that are created from these producer class. So I might have potentially tens or hundreds of these threads competing to access the same resource. So it's not reliable. If I don't synchronize, it's not reliable when you look up the data and you want to modify that data, right? You might not be accessing the most up-to-date information. So what can happen is same as the first example that we show. You look up the value, you get the value that might be right, but then at the time that when the time reaches that you would actually update these previous value has already changed, so that that value is no longer the most up-to-date one. Okay, so that's the reason why. That's a simple way to fix that. That's the way. That's the reason why we have that synchronized method. Any questions? So now let's move on to the safe box, the most interesting part of the code. The safe box, as you can probably imagine, is what does the magic of allowing all that to happen. So I have my get and my put methods synchronized. Why? Because I might have multiple agents using the same safe box, right? So I don't want to have multiple threads actually executing at the same time these methods, because again, these would be potentially changing the state of my safe box. So I don't want to allow, I want to create a mutually exclusive area here on that one safe box, okay? When I call get, I am trying to retrieve, right? So I'm gonna check if the state allows me to move on. If available is not true, this means that I cannot go on. Okay, this means that I need to wait until this state here changes. This state is telling me if I am able to do what I'm trying to do or not. Right? This state tells me that. So by checking that state, I am able to identify if I should be put in a wait state or not. If I put in a wait state, this currently running thread would be paused, and then it would need to receive a notify by some other thread before it can continue. Okay? When that happens, you would be just leaving this whole while block here, then you would update the available, right? Because you don't want the next thread to call get and be able to bypass that while, right? And then you would be notifying all the other threads. So you would be first letting other threads, if they are of the other type, so the get would be run by the consumer threads, right? And the put would be called by the producer threads. So when I call notify all, I'm essentially allowing the other threads that are producers to go on, but not the consumers, because I am a consumer and I already consumed that item. And my safe box only stores one item.
Yeah.
Right? Does that make sense? So because of that, I want to notify all. Notice again, you are notifying all threads, producers and consumers. But the producers would be able to move on. Actually, one of them would be able to move on, right? While all the consumers would not be able to move on. Okay. So then you just return the value that you got, right? And then let's see the other mirror implementation. So as I said, these would be the case of the threads that actually are consumers that are utilizing that method, while the next put method would be used by the producers.
So the reason why notify all did not impact the producers because because it was under the get.
Say it again.
So the above no,
The reason why notify would not.
impact the producers.
Okay. It would allow producers to move
Yes,
on, but only
Yeah.
because you have the lock, right? The synchronized lock. Only one of those producers would be able to move on. But the consumers, none would be able to go.
Explain again why consumers will not be able to access that if they were notified.
Because I am the currently thread that calls get is a consumer and it just retrieved the item. So you don't have any more item in the safe box.
Is it because of the notifier is under the get?
No, it's because of the currently thread running being a consumer. So what's the result of this whole execution here? The item would be returned.
Yeah.
So now you had the safe box empty, right? So how could another consumer come and get something from the safe box if it is empty?
Yeah, sure.
So that's why it cannot go on.
I get-
The threads would be notified actually. It would try to
But then
go
they-
on. It will try to acquire the lock, the synchronize. It might acquire the lock of the object, right? But then when it reaches this point, this would be true, right? This would not be available.
Yeah.
So then it would call wait. So it would be put in wait. So the lock would be released. So
Yeah.
another thread can come and try to do the same thing until one of those threads that acquire the lock are actually a producer that would be adding an element to that safe box.
So, till like the available is not true because it is inside while loop. Even if it is like released, like it wakes up, it will still be inside while loop if like there's another thing like.
Yeah, because it might be the case.
like,
right,
content. So,
yeah. It might be the case that you are waking up, but then you cannot do anything, right?
Yeah.
So then you need to check the same condition again. Yeah, that's why it's in that while loop. Any more questions?
The consumer gets notified and it goes into the wait state and a producer that doesn't get its chance, then it's in a deadlock state because.
Yeah, but in this case here, this would not happen, right? But yeah, that would be one example of deadlock. Because you would have actually, sorry, this would not be an example of a deadlock because a deadlock. Let me just quickly explain what a deadlock is. A deadlock is a situation where you have at least two parties and you have one party waiting on a lock of the other party. So that's the required criteria. So you need to have at least two locks, at the very least two locks, one lock being held by one party, the other lock being held by the other party. If that happens, that's a deadlock because you cannot recover from that. Right. So if you have you might be on the way to a deadlock if you have one lock being held, right? And then the other thread is in a wait state and potentially trying to acquire that lock. If that's not possible, then you would be in a state that the program would not keep going, but that's not technically a deadlock. It's just one thread that is waiting forever, but and not being notified, but not really, because for me to say that there is really a deadlock, I need to have all these conditions, just to be more precise. But that's also something that would prevent the.
Consumer goes into wait state and producer can't put in right because then that goes into like infinitely waiting.
Yeah, but as I said, this can happen, but this is not a deadlock. Okay, just to clarify the concept of the deadlock. I'll talk more about deadlock and I will have even some examples on deadlocks.
Go to the infinite waits.
Yeah.
In this problem.
Correct. Good. Same idea with the put method, right? So my put would be called by my producers. My producers would check for the negative of the condition, right? So my producers would not be able to move on if I have an item available, right? So that means that the safe box is busy, right? So if it is busy, if it is already full, I cannot add more items because it's not able to store more than one item. Then it would enter the wait state. It would release the lock, and then other threads might come. If other producers come, the same thing would happen. They would also be put in wait until one consumer come and retrieve the item. So now you change the state, and then one of those consumers would notify all, as we saw above, notify all threads. Then one of these producer threads can now go on and continue the put process. Make sense? So, and the main class is just setting everything together, right? So here I'm just creating two producers and two consumers and starting those things and then seeing what happens, right?